Hi everyone. In this lesson we want to look at how we solve a quadratic equation by a technique called completing the square. Now this is part 2 of 2 parts, and in the first part we looked at understanding how we solve in general an equation by completing the square, and here I just want to apply that to this example and another one or two. Okay, so if you remember from that first lesson, what I need to do when I complete the square is I need to group the first two terms together, x squared plus 5x, and this is the part that I complete the square on. So I'm going to take the 3 over on the other side of the equation, and then to complete the square take half of the middle term. And you don't have to think about decimals. It's much easier to do it in terms of fraction, right? Half of 5, which is 5 halves, and then you have to square that. So you always take half the middle term and square it. And of course, if I add that to this side, I'm going to have to add it to the other side as well. Okay? Now, this will always end up being a perfect square. This is going to be x and 5 halves and 5 halves. And plus, and you can verify, right? X squared and 2.5x from the outers and 2.5x for the inners makes 5x in the middle, and there's the 5 halves squared, which is going to be the same as 25 fourths. Let's write this as negative 3 over 1 plus the 25 fourths. Notice I left a little room here because I want to get a common denominator. Let's multiply here by 4 over 4. So this is now a perfect x plus 5 halves squared equals, and over on this side I'm going to get negative 12 plus 25. Well, that's 13 fourths. Now I'm in the position where I can extract the square roots. So I get x plus 5 halves is just going to be plus or minus the square root of the 13 fourths. So my x is going to be a negative 5 halves plus or minus, and then I can simplify this. That's just the square root of 13 over 2. So I could combine those under that same common denominator and say that's negative 5 plus or minus the square root of 13 over 2. Now this is the way we write our answer, so it's very succinct, but you do want to remember that there's two answers here, right? There's negative 3 plus the square root of 13 over 2, and you can do that on your calculator. You see that's about negative 0.69722. It's going to be an irrational number. And then negative 5 minus the square root of 13 over 2, that's this number, about negative 4.3. Now, the question did ask us to check our answers graphically. So if I were to use my graphing calculator to graph y equals x squared plus 5x plus 3, then if I look at the x-intercepts are where y is equal to 0. And of course, if y is 0, that's the very equation that I was solving to start with. So these x-intercepts should be the solutions that I found. Now notice that this does look like it's about negative 4.3 something. In fact, if you use your 0 button on your calculator, you can solve it graphically, and it says that the 0 is negative 4.302776, and that's exactly that value right there. And the other 0 over on the right is negative 0.6972. And notice that's exactly that value right there. So we have great confidence that this really is the exact algebraic solution to this quadratic equation. Okay? Now let's do another one. Let's solve this one by completing the square. This is 4x squared plus 8x equals negative 3. Now the significance of this example is that the leading coefficient is 4, it's not 1. And if you remember from part 1, the leading coefficient must be 1 to complete the square. Okay? Leading coefficient must equal 1 to complete the square. Okay? So, what am I going to do? Well, I need to make it 1. And I'll make it 1 by just dividing both sides by 4. Alright, so that's going to give me x squared plus 2x. And I'm going to set it up because I know I'm only going to complete the square on these two terms. I'm going to leave the negative 3 fourths on the other side. And then I can take half the middle term, half of 2 is 1, and square it. And I'll have to do that to both sides. So this is going to be a perfect x plus 1 squared. You can check that. You remember how you square a binomial. You square the x, that's x squared. And then the middle term is always this x times the 1 doubled. So x times 1 is 1x, doubled is the 2x here in the middle, and then the 1 squared gives you 1 up here. Okay, 1 minus 3/4 is 1/4. So now I can go ahead and extract the square roots. X plus 1 is going to be plus or minus the square root of a quarter. So x plus 1 is plus or minus a half. So x is going to be a -1 plus or minus a half. Now there's two answers there, and this one here I can simplify. This is going to be -1 plus a half, or -1 minus a half. Well, -1 plus a half, that's negative a half. -1 minus a half, that's -3/2. Okay, so there's my two solutions. Now, I might wonder, notice these turned out to be nice rational numbers, and if it ever turns out to be nice rational numbers, that means that you could have factored this original problem. That's an interesting little tidbit to know. And if you wanted to know how to factor it, if you knew these numbers ahead of time, you could work backwards, right? You could say, well, x is -1/2 and x is -3/2, and then you could get rid of the fractions by multiplying both of these equations by 2. 2x is -1 and 2x plus 1 equals 0. 2x is -3. I multiplied both sides by 2 here. Bring the 3 over. 2x plus 3 equals 0. Okay? So if I were to multiply these together, let's try it up here. 2x plus 1 times 2x plus 3. I think that's going to be the factorization if I brought the 3 over here. So it was 4x squared plus 8x plus 3. Let's try it. Well, there's 4x squared. If I take 2x times 3, that's 6x plus 2x. That does make 8x. And the 1 times the 3 does make 3, which is what this would be if I brought it over. So that really does work. And you see this is really powerful because it's going to give us a way that we'd be able to factor a quadratic even if I was having a difficult time factoring it. Because if I could work through this problem and find these solutions, I could always work backwards and get the factorization. All right, let's do one more problem. The significance of this example is that, again, the leading coefficient isn't 1, but when I divide to make it 1, I get kind of a nasty middle term. All right, so I have to divide. I have to get I want to group these two together, and so I'm going to go from this step. I'm going to write x squared plus 3/4 x, and then the -5/4, I'll take that on the other side. That'll be a plus 5/4. Now I need to take half of this term and square it. Where students make a mistake doing this is they try and do too much in their heads. What you want to do is just come over here on the side and just think, well, half of 3/4 squared. In fact, that's all you have to write here. Just take half of 3/4 squared. And if you do it to this side, then you want to do it to the other side as well. So that's going to be 3/8 squared that I'm adding to both sides. And this actually helps you when you go to factor it, because you know it's going to have to be x here to get the x squared, and you know it's going to have to be the 3/8 right here to get the 3/8 squared, right? Because this is 3/8 squared, and then you're going to put a plus right here in the middle because this is plus. Just double check it. If I square this out, I would get x squared, and remember the middle term is this first one times this second one, so that's 3/8x, and if I double 3/8, that'd be 6/8, and 6/8 is sure enough 3/4. Now over here on the other side, I've got 5/4 plus 9/64. So notice again I left a little space right here because I want to add in what I need to get a common denominator. I'll multiply here by 16 over 16 because that'll give me a denominator of 64. So this is x plus 3/8 squared is equal to 80 plus 9. That's 89/64. All right. So I'm going to extract the square roots. X plus 3/8 is going to be plus or minus the square root of the 89/64, which is plus or minus the square root of 89 over 8. So my x is going to be a -3/8 plus or minus the square root of 89 over 8. And I can put those together. -3 plus or minus the square root of 89 all over that common denominator of 8. And so this would be my answer. And there, notice again, there are two answers here. Negative 3 plus the square root of 89 over 8, and then another one, negative 3 minus the square root of 89 over 8. And I could, again, plug those into my calculator if I wanted to get a decimal approximation, but at least in algebra class, we'll typically just leave our answer like that.